Hello everyone, and thank you for joining us today for our first training workshop. My name is Christina Olsen from the CAPITALISE project, and I'm here with Dr. Louisa Diva, the ADAPT project coordinator, Dr. Markus Teige, the CAPITALISE project coordinator, Dr. Jeremy Carbinson, Professor Tracy Lawson will be joining us as well, and we also have Dr. Clara Panzarova, Dr. Kirsten Newman, and Dr. Eel Frieden. And together we are hosting this workshop on how to employ phenotyping of photosynthesis-related parameters to measure stress tolerance in crops. This workshop was initiated by the CAPITALISE and ADAPT Horizon 2020 projects. So we're going to start with an introduction to the ADAPT project by Dr. Markus Teige.
Okay, so I hope now it's okay. Welcome everyone. My name is Markus Teige. I'm the coordinator of the ADAPT project. And ADAPT deals with investigating molecular acclimation to stress responses in potato. So ADAPT stands for Accelerated Development of Multiple Stress Tolerant Potato. And our goal is to make potatoes fit for the challenging growth conditions of the future. And the idea of today's workshop was that we illustrate a little bit which technical possibilities are there to look into molecular mechanisms of acclimation. Because this is a very urgent topic for basically all EO projects. If you are looking into the guidelines of European research, ADAPT is at the crossroads of the European Green Deal that addresses the question, how will people, economy and ecosystems be affected by problems of climate change? And if we look at a recent publication that has been published in Nature Climate Change in May this year, there are dramatic losses of economy coupled to these problems to reach 65 billion euros by the year 2100. And currently it's also estimated that the impact is about 9 billion euros per year. So how will this affect the different crop types we are working with? So if we look, how will this affect potato? We can clearly see that potato is a cold climate crop. It is originating from the cold regions of the Andes, and it is very sensitive to high temperatures, particularly if they occur during the night, because higher temperatures do clearly inhibit tuber formation, and thereby they lead to dramatic loss in crop yield. And if this is coupled then again with drought stress, this leads to dramatic changes in the harvest. So we made a survey among the potato growers and tested how the experience is for the potato growers, and they confirmed that drought and heat stress is in fact already during the past 10 years the most important thing for them, and they think that this will also stay like this in the future. So we want to address now how molecular understanding of stress acclimation can help to develop stress-tolerant potato varieties. And we are doing this in a network composed of different partners. So we have at one hand side the academic partners that are investigating stress signaling and molecular physiology and molecular acclimation, together with breeders and technology developers. And this is a part where the different things are coming together. So we are approaching these problems from different sides. So we have a phenotypic approach, the phenomics, where we have genetic variation in different field types. But the topic of today is how the dynamic of these processes is looking like. So how will photosynthesis change and what is the dynamic of these systems? And this should then feed into modeling to predict performance, and that can be later on confirmed by directed approaches. And we have different field trials ongoing in Spain and in the Netherlands. And we have to look into these molecular mechanisms in a very high resolution. And here you will see, here you see some pictures taken from PSI, from a pilot experiment that has been in the first phase of our project. So here we are looking at the question how the dynamics of these processes is regulated. And this will guide us for our sampling for the approaches that are going more into detail. And I do not want to go more into detail now. So here we will need the detailed phenotyping to look beyond greenness. So we will not only have these endpoint measurements, we will just say how photosynthesis reacts to these stress responses, and this will help us to understand the molecular acclimation. I will stop here, just refer to our homepage and to our Twitter account. And last but not least, I would also announce that we are organizing a conference in September this year, where we still have slots open, and you are welcome to join this conference if you are interested in plant signaling. And with that, I would like to end and hand over actually to the speakers.